Section 5.3 is slope-intercept form. I can write linear equations using slope-intercept form, and I can graph linear equations in slope-intercept form. Those are our learning targets and what we're shooting for in this section. Big ideas here. The slope and y-intercept of a line can be used to write and graph an equation of the line. One form for writing the equation of a line is the slope-intercept form. A family of functions is a group of functions with common characteristics. A parent function is the simplest function with these characteristics. The linear parent function is y equals x or f of x equals x if it's in function notation. Linear parent functions form a line. A linear equation is an equation that models a linear function. So again, it forms a straight line. You can connect it with your pencil, like we worked with in chapter 4. The variables cannot be raised to a power other than 1. Graphs of linear functions may cross the y-axis at any point. We call that the y-intercept. So a y-intercept of a graph is the y-coordinate of a point where the graph crosses the y-axis. So it's our y value where we cross. So where we cross the y-axis, our up and down axis, that value is our y-intercept. If we look at the take note on page 308, it's our slope-intercept form. Y equals mx plus b. M is our slope. It's going to be how we move on our graph. B is our y-intercept. It's where we begin. So again, M is our slope. It's our rise over run, how we move to get to the next point. And y-intercept is where we begin. And I know like a linear equation doesn't always have a for sure start point. There's arrows on both sides, but we can use that y-intercept to begin to plot our graph. So slope-intercept form, y equals mx plus b. Our framework here every time is y equals something times x. We plug in m, our slope. We plug in b, our intercept. Example 1 is identifying slope and y-intercept. We want to know what are the slope and y-intercept of the graph of our function here. Well, it's in slope-intercept form. It's a linear function, x is to the first power, and it's y equals. So as long as it's y equals mx plus b, we have it in slope-intercept form. So I'm going to compare this here to my slope-intercept form. When I do that, I see that my m has been replaced with a 5, and my b has been replaced. Remember, we changed from subtraction to adding the opposite, so that's a -2. We take the sign with that number. So slope is m, which here is 5. And y-intercept is our b value, which here is -2. So slope 5, y-intercept -2. Now give this one a try. We want to know what are the slope and y-intercept of the graph of our function here. So y equals mx plus b. So again, in both of these functions, it's y equals and y equals. Then we can compare. The coefficient of x is my slope, which here is a -1/2. My b value is what's added on after the fact, which here is 2/3. So slope is my m value. Here, it's -1/2, and my y-intercept is my b value, which here is +2/3. So that is my slope and intercept of my graph. In example 2, we're writing an equation in slope-intercept form. So it says, what is an equation of the line with slope -4/5 and y-intercept 7? Well, since we have a slope and a y-intercept, I'm going to go right into slope-intercept form. Y equals mx plus b. My framework here, the part that stays the same every time, is y equals slope times x plus b. So I fill in my values. M is my slope, which here is -4/5, and b is my y-intercept, which here is a +7. So my equation is -4/5 times x plus 7. Slope-intercept form. It's the equation of the line with slope -4/5, y-intercept 7. Give this one a try, please. Again, we want the equation of a line with slope 3/2, y-intercept -1. So because we're looking for the equation of a line, we're given slope and our y-intercept, we use slope-intercept form. Now, my framework, the part that stays the same every time, is my y equals times x. I plug in my coefficient, my m value, that's my slope, which here is 3/2. My y-intercept is my b value, which here is -1. So you can do plus -1 if you want, but when we simplify that, we end up with just -1. So my final equation here is y equals 3/2x minus 1. Example 3 wants us to write an equation from a graph. So we want to know, what is the equation of the graph on page 309? I have a picture of it here, kind of. Well, it's a line, so we're going to start off with our formula for a line. Y equals mx plus b. So here, we need to figure out what is m and what is b. Those are the pieces of my formula that I have to plug in, because again, my framework is y equals something times x plus b. My y-intercept is where I cross the y-axis, and remember, this is my y-axis. I cross at -2, so b is going to be -2. It's where I begin. Now, I can find my slope from any 2 points on the line. So because I'm already using that -2, I'm also going to use this one. But I could have used here, or here, or here. We usually want to pick points that are easy to determine. So like where they meet on corners are good points to pick. And I have 5 points here. I could do any combination of them because it should reduce down to the same thing. Remember, to find our slope, it's going to be rise over run. So between my 2 points, I'm going to use these two. I go up 2 and run 1. So my slope is going to be 2. I plugged all of my information in now. M equals 2. X, b is -2. So my equation here, y equals 2x minus 2. So I found my slope from my graph, up 2/1 from any 2 points. I found my intercept where I crossed the y-axis at -2. I plugged those in, so slope times x plus intercept, which here is a -2, gives me y equals 2x minus 2. Feel free to try this one, please. What is the equation of the graph on the bottom of page 309? So again, I'm going to start off with slope-intercept form. It's my equation for a line. My framework is y equals something times x plus b. So I'm going to figure out what m equals and what b equals. Those I have to know in order to plug into my spots. B goes here, M goes here. Now, my intercept is easy to see from my graph. It's where I cross the y-axis. So it's always where my line crosses my up and down axis there. Here, that value is at 2. My slope is my rise over run between any 2 points on my graph. And if we look here, it seems like these meet on all these corners. So we can use any 2 of them. And again, to find slope, it's rise over run. So I'm going to use these 2. Again, it doesn't matter. Any 2 points we can use. I go down 1 over 1. That reduces to be -1. So my slope is -1. I can take those and plug them in now. Y equals -1 times x plus 2, because it's a positive 2. That would work. But we also don't need the -1. We could just say it's a -x. We don't need the 1 coefficient. So either one of these works. Remember, also, if you see an equation in this bottom form, it means that there's a 1 there. So even if you don't see the 1, know that there is 1 there. So that gives us our equation of our line. It slants downward like if you make a capital N. So it should have negative slope. Ours does. So that's one more quick check along the way. Example 4 wants us to write an equation from 2 points. What equation in slope-intercept form represents the line that passes through the points 2, 1, and 5, -8? So here, in slope-intercept form means I need y equals mx plus b. My framework again is y equals something times x plus my intercept. So I need to know what is m and what is b. To find m from 2 points, we use our slope formula. Change in y's over change in x's. Plug in our values. I'm going to do -8 minus 1. Since I used -8 first, I have to use 5 first, minus 2. This is going to reduce to be -9 over 3, which is -3. So my slope is -3. I can plug that in. Now, I still don't know what b is. So what I'm going to do is I'm just going to plug a b in there. This is all the information I have. I don't have anything about an intercept. What I do have are some points. So I can take my points here. Doesn't matter which one. I'm going to pick this one. It's an x and a y value. So I can plug those in for x and for y. And when I do that, I can solve for b. So to solve for b here, simplify so that my left and right sides are as simple as I can get them. Then to get b by itself, I add 6. So 7 equals b. Now that I know what all of my pieces are, I set up my framework. Y equals something times x plus b. My slope, -3, intercept, +7. So y equals -3x plus 7. So again, when they don't give me a y-intercept and I don't have a graph to pull it from, I need to be able to find it. And the only information they gave us were points. From our points, we found our slope, plugged that in. So then I had just one thing I didn't know. I knew some x and y values, so I could plug those in and solve for b, the piece I didn't know. Once I did that, I plugged it in and had my equation. And I will continue this section in another video.